Hello and welcome to video 2 of Introduction to Python using Jupyter Notebook. In this video, we're going to load a data set into Jupyter. We're going to talk about how to obtain descriptive statistics, talk about methods and method chaining. We're going to go through how to create new variables and recode existing variables, and then compare means using independent samples t-test. So I have our Jupyter Notebook filled out here. I'm going to go back to this main one. And so let's go ahead and now we're going to talk a little bit about working with a data frame. So the WDI, the World Bank indicators data set comes in an Excel sheet. So I'm going to go ahead and pull that up really quick so you get a sense of what it should look like. It's always good to double check things. We'll give that a second. So it is in a tidy format, or sometimes called a wide format. Each column is a variable, and each row is a country. We have missingness here. We have a mixture of string variables, a mixture of values and numerical values here. That's fine. One thing I want to mention here too is it is wide format because each country is only listed once. If we had multiple years, that'd be more of a long format. So we'd have Afghanistan for a couple of years and then Albania, Algeria, and so forth. So now we can check that. We're going to go ahead and we're going to import using pandas. So before we had imported pandas as PD. And this is helpful because rather than typing out pandas here, we can just say PD. And from PD, we're going to use this read CSV method. And then we're going to say what our specific data set is. And we have this additional encoding because that's some of the encoding that was with the data set too, or the file, just to make it easier to read. We want to print out the DF. So I'm going to do that. And here is our DF. It gives a head and a tail, so we can kind of see what it looks like. Any null values is NaN, and it matches specifically to what we had before. That looks great. We can also use a method of, after doing that, you always want to kind of double check, make sure, is it reading incorrectly? So I like to use the head and tail methods here. So we say, we refer to the data frame name. So we had to call this called df. So that's what we assigned it. That's the object. And then dot method of 5. So for the head here, it's going to, by default, it's going to be 5. We can change this to 2 and then run that. We can also change it to 10 and run that. Now we have the first 10 positions. And then we can also, if we just leave it empty, it's going to default to 5. So we just take a quick scan of that. That looks good. We can also print out the last 5 cases, make sure that looks good. We can also do things like double check the variable information. So we use the info method for this, and we can check, okay, we have the different variable index, how many non-null values we have in each one, and then the data type within this. Great. So then we can also do things like rather than the entire data set for head and tail, we can refer to a specific variable. So when we want to do that, we'd say what the object name is, in square brackets, what the variable name is, and then use our method. Here we're going to use head. So I'm going to go ahead and we have the first 5 countries. From those first 5, the corruption values and our literacy. Great. We can then also do things like we can print out a specific, like if you wanted accounts for the values, give it the L. So say df, and then specifically I want the counts of free new, and then print that out. So it's going to give us the frequencies of how many are free, how many partly free, and how many are not free within that variable. Alternatively, rather than this, we can also do multiple variables by saying country corrupt literacy. We're saving that list of variables as something called select, then saying df use the list select head 5. And when we do that, it prints out just those 3 variables. So that's another quick way you can kind of subset your data just for getting a sense of it. Now we can go back to our free count we have. Actually, I'm going to go ahead and move this up. Oh, I think I just lost it. Let me, there we go. Just so it makes a little bit more order when you use this yourself. Now I'm going to take this object we called free count. That's our frequency table here. We saved it as an object, and now we can say take the free count object. We're going to use a plot method on it, and we want a bar chart. So when we run this, within the text, we get a bar chart of free, partly free, and not free. Really, really basic visual there. We can also do things like crosstabs. Like I'm going to use the PD. So using pandas, I'm using the crosstab method, and I want our OECD membership and our free new. So this is going to be our rows, this is going to be our columns, and we have margins true. So now we have whether or not they were a member, and then whether or not they're free or partly free, and then the total counts. Great. So from this, we can also do things such as using multiple methods. This is sometimes called chaining methods. So here we're going to do is we're going to do df free new. When it equals free, I'm going to sort the values of corruption and give me the first 15 of those. So the highest corruption values, because we sorted it for just those that have that free, for that free new. Another thing we do too is we can actually create a subset of data set if conditions are met using logical operators. So if we want to use equals not free for the free new variable, and we're going to assign that to mask. Now, when we do df mask, it's going to use that filter and say, okay, give me back the df for mask. And we can go ahead and pull that. We could also save that as a new object if we really wanted to too. We can then also say mask2 literacy, and the condition is if literacy is greater than 99, that's going to be a mask that we can then subset our data by. And we can then save that subset as a new data object. We can then also do things like run a query. So let's look at the People's Republic of China. So we're going to go ahead and run a query method on our df object, and the logical operator is country equals China. So we have our double quote here because that's the value, but we have the logical operator within a single quote. So we're mixing and matching that. We run that. We specifically pull up the record that's associated with People's Republic of China. Now, before, we mentioned earlier that corrupt is reverse coded, so higher corruption scores actually reflect a lower perceived corruption. I'm an experimental psychologist by training, so I'm going to flip that. So I want higher scores to reflect higher perceived corruption. It just makes more sense in my mind. So what we're going to do is we're going to create a new variable called corrupt2, and that's going to be a function of 10 minus each country's current corruption score. Now I'm going to go ahead and go back up to our previous one where we had our select. Too far. And I can go ahead and do comma corrupt2. And now we can look at 2.5. It's now 7.5 out of 10, so that makes perfect sense. Now I'm going to go ahead and remove this. That way it's not going to throw an error later on. But we can quickly jump back and forth and make changes to it, which is great. And all the code, all the comments, all the results are all in a notebook. Makes it super easy to work with. Let me go ahead and just save this. It does do checkpoint saves, but I just like to always kind of just do that really quick, just to be on the safe side. Okay. So now that we've done that, we can also categorize a continuous variable. So sometimes it's easier to think about a variable in term rather than a continuous one, that it's in high, medium, and low groups. This is sometimes called discretizing a continuous variable or categorizing it. We're essentially binning this. So a quick word of caution. So you get my 2 cents on this because I'm the one who's doing the video. So we have 0 and 10. That's our perceived corruption scores. So we have some values here, and we're going to bin these. So we're going to do whoosh and whoosh. So what we're doing then is we're treating all the values within this first bin as the same, all the values in this next bin as the same, and the third bin as the same. Now let's say we have one that's right here and one that's right here. They're more close to each other than to the group centroid. But because we're binning them, we're saying, well, they're not the same, even though they're so close to one another. Um, the issue with this is you lose potential variance or variability within this. So I'm not a big fan of it. I understand why people do it, but my 2 cents. Just use it with caution, as with anything. So what we're going to do now is we're going to go through how to do this. Again, I don't recommend it. I don't think it's good practice at all within my field. It's not recommended, but it is another field. So just a word of caution. So what we're going to do now is we're going to go ahead and I'm walk you through how to do this. We're going to create a function. So we're using def, and that's helping us create a function here. And we're calling the function catig. We have a series. This series is going to be a placeholder for whatever variable we're going to add into it. So we're saying if series, and pretend series is corrupt2, is less than 3.4, it's going to assign it as a low. If for each country, for that specific country, if it's between 3.4 greater or less, if it's greater than or equal to, or if it's less than 6.7, it's going to be a medium. Else if it's greater or equal to 6.7 but less than 10.1, it's a high. And these are all mutually exclusive. That way, no country can be in two bins. So I'm going to go ahead and create our function. And now what we can do is we can say for corruption2, we're applying our user-defined catig, our user-defined function, to create corruption catig. And then I'm going to ask for the counts within this. And now we have the counts within the data. I can then go ahead and I'm going to add a new cell. And then head, so I'll do df head. And we have our corruption high, high, high. So we can just do it as a quick spot check. And that looks good. Great. So, descriptive statistics. So, some of the questions you might have about your data, you want to really look at descriptive statistics, then look at graphs and statistical significance tests. We're going to start with the average or mean of corrupt2. So, to do this, we're going to say mean df corrupt2. When we run that, we get NaN. That's because we have missing values in here. So, in order to fix this, we need to drop NA. So, we're going to subset our data for just GDPPC and corruption2, and we're dropping if they have any NAs in there. So that way, when we run things like this, it's going to go ahead and break up this cell. And that way, when we do this, we're getting the means for either of them. And I'm going to go ahead and break up this cell too. And sorry, you get to see me do this. I quickly copy and pasted this and forgot to break these up a little bit. So let me go ahead and fix that. In the copy you'll be able to get online, this will already be broken up. The nice thing is it's super easy just to make these changes. And there we go. Great. So let's go ahead and start running these. So we got our means for our two variables. We can also get our medians. And then we can also get our standard deviations, our variances for both variables. So we're using, again, just saying what referring to what variable within df complete. That's one that we dropped the NAs from. And then a method. So we had our mean, median. These are just basic functions. Now we can use a method here of standard deviation, our method of variance, getting those. From here, we're going to use the SP and the skew function from that to get corruption2, and then the same thing for the skewness of GDPPC. We can also do kurtosis for either of these, and that looks pretty good. An alternative approach is to use the describe function within this, or the describe method. I use method and function the same because in my mind, it's the same thing. But yeah, so what we're going to do here is we can get the counts, mean, standard deviation, minimum, quartiles, maximum. Same thing here. So you can use this. No, we placed a lot of the code beforehand. Great. So let's say that we wanted to look at means of different groups. So here we're trying to determine whether GDPPC differs based on corruption categories that we had created earlier. We'll start with subsetting the data on each of the three groups and then save them into different data frames. So we'll be creating a low corruption, medium corruption data frame, and a high corruption. So what we're going to do is we're using our complete data, and when corruption category is low, subset that and save that as low corruption. So we're creating subsets of our data when each of these conditions are met. So we'll have a data set of low, data set of medium, data set of high. So now that we've done that, we can then compare the different groups. Now, t-test, you can compare only two groups based on the scores of a single outcome variable. We did divide corruption 2 into three categories, but we can only compare two groups at a time using a t-test. If we wanted to look at all three together, it'd be one-way ANOVA. First, we need to check the underlying assumption of the variability in GGPPC between the low and the medium groups are not statistically different from one another. This is called homogeneity of variances or Levene's test. So if the p-value is less than 0.050, then we have to use a correction to account for that violation. So here we don't want statistical significance. So we're going to go ahead from, we're going to use the SP module and using the Levene test and saying GDPPC of low, GDPPC of medium, and we're printing that out. Here it's not significant, so we didn't violate that assumption. So let me fix this comment. So we use false for unequal variances. Okay. So now what I'm going to do is like if we needed to make that correction, we would change equal variances here from true to false. So I'm going to use independent samples t-test saying what the data frame is, and then because that's essentially a grouping variable, and then GDPPC. In here we have our t statistic, our p-value, and our degrees of freedom. So we'd report this as t parentheses 42 or 72 and parentheses equals 4 point, or this would be 9.87 and p is less than 0.001. So that's how we report that. Let me make a quick note. Okay. And then before you had to calculate degrees of freedom, so I'm going to leave this in there just in case you're interested. So we just get the length of each of our variables here, or data frames. We print them out. Let me go ahead and break this up a little bit. So we do that, 23. What we do is we take the two together, minus 2 for the two of our groups, 72, and that's where we got that number. That matches up perfectly. Great. So we're going to go ahead and stop here, and we'll finish up the series in video 3. I'll see you in the next video.